Kurs. I'm from Software Composition Group in Bern, and today I will talk about parsing contexts. Probably right now you have no idea what does it mean, this context, but at least you know what is parsing. And for those who does not know parsing and petit parser, I introduced a small demo in the beginning so that you can catch up, and in the end I hope you will understand the context as well. So as an example, I prepared this small Python code or Python-like code, and from the parser point of view you can see that there are some things like keywords, some blocks of commands, some identifiers, etc. So if you are new into the petit parser and you want to implement a petit parser that can handle this code, you can start, for example, with the keywords. It's a very simple thing, and you just try, okay, my if keyword is a if as a string, and I want to create a parser, this parser that can recognize the if keyword. For the rest of the presentation, I will remove this as parser because it's just pollution in the code. If you have something more complicated like identifiers, you probably know you can do things like similar to regular expressions. So you define identifiers as a letter followed by a sequence of letters and digits. That's quite easy, and that's the way how you do this in petit parser as well. In the end, there is a more complicated thing, which is a block of commands. If you want to define a block of commands, you can write a code like, okay, my block means I will have the indentation, which is this space here before the print, and then I will have several commands, and then I will have a indentation. It's actually a rule of a Python. But the problem which we have is that petit parser actually does not. The problem we have that actually we don't know how to define this indent and dedent. Why don't we know this? Because the petit parser is in the situation you see here. I removed the code around. So if you have this information, you cannot decide if the code is indented or dedented. And that's the problem. You don't know how to define this. I prepared this slide to understand state of the art right now. There are several categories of the languages. I divided the languages into the 3 categories, but it's just for this presentation. There are much more categories. The simplest one are the regular languages, and you can express the regular languages using the regular expressions. Everybody probably understands this. Context-sensitive languages, which are the most complicated languages, can be expressed by anything which is Turing complete. But if you saw the Turing complete thingies, nobody wants to do this. So, okay, not nobody, but it's complicated, it's hard to express. Right now, state of the art in the parsing is somewhere in the middle, and there is a petit parser as well. You have something that is reasonably simple and reasonably expressive at the same time, and that's a petit parser as well. That's a parser for Faro and Smalltalk. The problem is that not all the languages are in this category of context-free languages. It happened that this indentation and dedentation thingy from Python is in the context-sensitive languages. So petit parser is like cannot reach this feature, and this feature can be easily reached by a Turing complete parser or whatever. So what's the goal of the parsing context is to move the petit parser from this category a bit higher, so that it can reach more languages. And we do this by using parsing contexts. So how we do this? To understand this, I have to mention that the petit parser is a parser combinator framework. What does it mean? If you have this regular expression, which is a petit parser code, we translate it into the objects like this. Every single operator here is represented by a particular parser combinator. Combinator is represented by this half here. So if you have this comma here, it says, I am a letter and then sequence of something. And you can see on the object here that this comma refers to the letter and to the star parser combinator. The parser combinator works in very easy, very simple way. It accepts a string as an input, and as an output it produces another string. So in case you have a parser combinator that can accept one letter, and you put a hello string inside, the result of the parser combinator is hello without the leading H. That's the state of the art right now. So to return back, we had this problem that we cannot decide if this code is indented or dedented. And we were a bit unhappy about this. But if I can provide some kind of information, in this case I provide this information in this arrow. Now I can see, okay, the code is indented because it's to the right for you from the code. So what we did actually, we have extra information, and maybe now we can implement this indent and dedent commands. What we did is to extend the information to the parser combinator of the petit parser from string to string and indentation stack. If you have these two information, somewhere here there could be some kind of magic that can decide if the code is indented or dedented. Because this solution is only for one particular case I use in this presentation, we can generalize the case for more cases, and we call this parsing context. In general, the parsing context contains the original string, but it can contain any other data as well. In case of this presentation, I use only indentation stack, but if you have another problems, you can put another information into the parsing context. And here the magic can do more stuff because it has more information to decide. So, if you have this extra information, you can easily implement indent and dedent like this, which is not actually so cool as we would like to. So, what we did is actually move, this is our goal, but we moved somewhere here. And we don't want to do this. So, there's another question, how to make it simpler again. We do this by dividing the users into the two categories, grammar implementers. These are the guys who just want to implement their grammar, and they are framework implementers. These are the smart guys who understand the deep insights or how does it work. For the grammar implementers, we stick with this notation. This notation is called context-free. This is the rule for the context-free languages, the original ones. And it's pretty simple. People can handle this. People understand this. If you show it to somebody, you can understand this. So the grammar implementer see only these rules. So if he wants to write his code, he just writes indent command and dedent. But there must be another guy who implements this indent and dedent for the others. And this is this framework implementer. The cool thing here is, once you implement this block of code, you hide it behind this variable. You don't have to care about how complicated is it. So you hide the complexity of these context-sensitive languages somewhere behind some kind of variable or some kind of rule, and you can reuse it whenever you wish in the future. So what happened? We moved from very complicated thing back to a bit simpler thing, at least from the user perspective. And actually that's all the work we did. We are happy here and we have what we wanted. Indentation was just the example I used in this presentation to understand the problem, but we used this approach for, we use this approach for tolerant parsing for type-def feature of C++ and recursion. It was not possible to do all this stuff, at least for me, in petit parser. And this parsing context, most of the features can be handled with them. I'm just now experimenting with recursion a bit, but it's just a research project. But to show you that it's a general concept, it's not a concept only for indentation. If you want to give it a try, there's the indentation and tolerant parsing extension on GitHub. Is it? Oh, Smalltalk. So you can give it a try or ask me after the presentation. To conclude my talk, the goal of the parsing context was to push up the petit parser from this category a bit higher. How did we did it? We extended the information put into the parser combinators in petit parser, and to keep the thing simple, we divided the users into two categories. One sees the simple stuff, the other one has to do the hard work for you. And yeah, we can solve several problems with this. That's the end of my talk, so if you have any questions, please feel free to ask.
So I have two questions. One is, how do you compare this work with Ometa's argument for production rules?
Ometa argument production.
Production rules with arguments in Ometa.
It's more like attribute grammars, I suppose.
Not really.
Maybe we should take this
Yeah,
offline because you have to show me how exactly does it work.
Yeah, they maybe have yeah. It's not a very great way to implement it, so I really should like to talk about it.
Okay.
There's a simple implementation of doing upside doing like this. My second question is what's the problem with the recursion?
What's the problem with the recursion? In Petit Parser, it's a peg-based thingy.
Is that the left recursion?
Yeah, it's a left recursion and it gets into the infinite extent. So maybe the context can keep some information and at some moment you can decide to stop this.
Happen to have like two solutions for it.
Yeah.
I thought someone had done left recursion in Petit Parser as well, but I don't remember the reference.
There is a thing, there is a memoization thingy, and the memoizing parser remembers how many times it entered, and when the number of entrants is greater than the size of the string, it gives up. But it's an escape strategy. It does not ensure that you will have properly parsed input.
Can you do that by rewriting the parser tree?
No.
Write recursion or something that you can eat?
Sorry, again, the recursion?
Basically the grammars, the left recursion, you can rewrite it by introducing new rules or something.
Sure.
Other kind of recursion that you can manage. And since your parser is actually a tree of parsers, I think it shouldn't be that difficult to rewrite the tree to eliminate the recursion.
Normally in the literature you have this phrase like left recursion is not a problem because every grammar can be rewrite into the right recursion grammar and then you solve the problem. But in practical things, for example, why the Petit Parser is popular is that it's top-down parser and what you define is what you see while parsing. But once you rewrite your grammar somehow in the background, it's hard to match your grammar with the thing that's happening, and people are unhappy about this. So that's the reason we try to figure out how to do this with the left recursion.
Another question related to the parsing context. It seems to me that you are trying to bring during the parsing phase something that you might be able to do in a let's say post-processing phase.
Exactly.
Something like, for example, the spaces, you can just count them, add them to some kind of an intermediate block, and after the parsing is done, you can just have a tree walker that will rewrite again this rewriting stuff.
You're definitely right. Whenever you have a context-sensitive feature, which is actually even the if-then-else is somehow context-sensitive because of the dangling else problem. The general approach is to have either handwritten parser or have a generalized parser that returns several results, multiple results, and in the post-processing phase you choose the result that you like. But a problem with the Petit Parser is that it does not return multiple results. It chooses only one and that's your thing. And sometimes, for example, in case of this tolerant parsing, you get several results, and how the heck shall I know which one is the correct one? I expect from the parser to tell me. I want to define it in a grammar, I don't want to do the post-processing phase. So from this point of view, I think it might be a good way to go.
I just wondered if you looked at Lawrence Tratt's paper, Direct Left Recursing Targeted Expression Grammars with equalizers and unambiguous algorithm for parsing left recursion with pegs.
What's the name of the algorithm? It's a growing seed or something
it's
else?
It's based on that, but he extends it a bit and it provides unambiguous.
Might happen, I saw that, but I will have a look at it. I will ask you for the reference. Thank you.
My question isn't exactly relevant, but I wonder what could you are you making progress with building faster parsers by post-processing the parser combinations?
faster parsers.
Well, I mean, you know, parser combinators are extremely slow.
Yeah,
So,
exactly.
any tools to construct more conventional parsers from?
I'm not aware about this.
Yeah,
Like,
actually, there is some kind of petit parser rewriter that enables you to do that. And I wrote a VHDL grammar that, without optimization, was like not able to parse like a big VHDL programs. With some optimization, you would improve that very much. With some others, you will just kill yourself again.
Right.
So yeah.
So maybe we can talk afterwards.
I would be actually interested as well, so I will try.
Yeah.
As you know, I try to use better parser-based parser to parse Java, and obviously it turned out to be painfully slow. So I introduced various tricks, but in the end, then the main problem is that I simply didn't work out how to implement the cuts in the backtracking. So is it possible to use this context to implement the cuts in a prologue kind of way? You know what I mean?
Yeah, I know exactly what you mean. Student of mine should have the implementation of the cuts.
Okay.
And if he was like, he did not manage to do this in the deadline, so he did not introduce the code for me, but he used the implementation. But
So
I think
you can send me an example in a week's time.
actually, I think you can implement the cut without the parsing context. You just have a parser that says this is a cut and stop it. Maybe you need some modification in the choose part, in the choice parser, but that's all. You don't need parsing context for doing the cuts.
And you know, if you did you implement a tokenizer?
Yes.
Yeah, that makes a huge difference, but not enough.
Yes, I have a tokenizer, and then on top of it, I got because it's still I hit like a rate buffer with I don't know last 100 tokens, so I don't have to reparse from the character stream again. It saved me like 80% of the time of the original, but in the end still wasn't the end.
Yeah, but we are solving another problem.
Yeah,
The
sure,
parser
sure,
is
but
used for
I mean-
prototyping. You just quickly
Sure,
give it a try.
I was prototyping my
Yeah.
stuff, but then the cuts would probably help even more. And
We
that
are
is
working
some-
on this, and the cuts may help even when reporting the failures as well.
Yeah.
That's the
I
reason why.
just couldn't find out how to do it.
You need extra parser, you need extra combinator to do this.
I tried various things, and well, maybe I just didn't understand
Okay.
how to do it.
We can talk about it later.
Maybe a good example in the documentation of the code.
I will do this. Any other questions? Yeah?
I'm not sure how to describe it, but I'll give it a try. So, why is it that the grammar cannot make reference to variables stored locally in the parser, such that, for instance, one could write something along the lines of, I don't know, indentation variable equals, count the number of spaces, tabs, whatever, at the beginning of this. The next thing that would hit would probably be a statement, I guess. And the production of the statement would be, well, this is a statement with a copy of the current indentation, and perhaps if one wanted to be super fancy or super, I don't know, stupid, one would have a last statement variable, and one could have also in production grammar that, hey, if you just made two of these at the same level, then, well, that's, concatenate and make a block. Is that ridiculous? Probably it is, but one learns, so.
No, it's a good question, and if I understand that properly, so
Maybe I don't understand it properly either.
no.
Yeah, that's like if you are doing it in all meta, yeah, that's how you do it.
I suspected, but I didn't want to assume.
The problem is the visibility of the variable may not be as great as you need, right? And the context is visible to every production in the grammar, whereas the variable is only available to instances of that one production. Right? So it Depends how
Yeah.
you write the grammar. People do indeed do that kind of stuff.
I meant the variables to be global to the scope of the parser, so it would be
Yeah, you
possible
can,
to all of them.
yeah, it's,
But I don't know, maybe it's
that's, yeah, we can do it.
But once you make it really global, you actually get to this parsing context. Because
Yeah,
as you said, for me it was like, why the heck can't I specify my Smalltalk? It's here. I know it's a not nice code, but it's actually not so complicated. This part, it's not so complicated. I just wanted some variable. I actually even calls maybe some parser inside, but I just need to do the decision based on the variable size, whatever. So the simplest thing was just, why do I have only string? Just put their string and some extra information I need. That's all to think about. Of course, you can have more like cool, like this stuff, like more formal stuff, and it's called context-sensitive grammars. But nobody can understand this because the rules are like really like, you know, it's very hard to understand this. So, and people say that the parsing is a very well-known problem, but as you say, like very simple problems we cannot solve. So the usual approach for doing the grammars is people just sit down and write down the top-down parser from head because it's easier for them to do this kind of stuff.
Okay, thank you.